welcome to channel Knowledge of Friends. Subscribe to our channel and click the bell icon for the latest update. Today we're going to discuss about the physics for class 11, that is of part 1, which we had started with, and this is your class 49. We had done your 48 classes of the sessions in the last classes. In 48 we had started in the last class, that is your unit 6, which is your work, energy and power, where we had completed about the introduction and the scalar product, which are related to the commutative law and distributive law as well. We did numerical as well. So now we continue with another topic, that is the notions of work and kinetic energy, the work energy theorem. So let's go for it. So before starting with the same, it's a huge request to all the viewers, so please go ahead with like, share and subscribe, so that many maximum people can get the information at once, and you can also enjoy the video as well. Let's go for it. So first we talk about the topic, that is your notions of work, notions of work and kinetic energy, the work energy theorem. Now for the same we go for it, and we'll discuss about the following relation for rectilinear motion, that under the constant acceleration a that has been encountered in the chapter, and that we have as follows, which is v square minus u square equals to 2as minus u square equals to 2as. Here where u and v that are the initial and the final speed, and s is your the distance traversed, and multiply both sides by m by 2, then we get multiply both side m by 2, so we get half mv square minus half mu square equals to 2as on m by 2. 2 step cancel a, that is a mas, so it will be mas, which is equals to fs. ma is your force, so fs. So we are the last step that follows from Newton's second law. We can generalize to 3 dimensions by employing the vector, which is v square equals to minus u square equals to 2ad. Here once again multiplying both sides by m by 2, by m by 2. Here we get half mv square minus half mu square equals to mad, which is equals to f and d, that is force and distance. So now the above equation that provides a motivation for a destination of work and kinetic energy. The left side of the equation is the difference in the quantity, half of the mass time, that the square of the speed, and from its initial value to its final value. We call each of these quantities the kinetic energy, that is denoted by K. The right side here, the product of the displacement and the component of the force along the displacement. The quantity is called work and is denoted by W. That is, we have kf minus ki kf minus ki equals to w. So kf minus ki, where ki and kf are respectively the initial and the final kinetic energy of the object. Work refers to the force and the displacement over which it acts. Work is done by a force on the body over certain displacement, where that is also the special case of the work energy theorem, that the change of the kinetic energy of a particular is equals to the work done on its by the net force, and we shall generalize the above derivation of to verifying forces in the later section. Let's go for the detail here. So I just write it down for you all so that it will be helpful for you and to be generalized here. So let's go for the same. The first we write about work is done. So work is done by a force on the body over a certain displacement okay. Now talking about for the special case of work energy theorem. So for that work energy theorem we have work energy theorem states that the change in kinetic energy of a particle is equal to the work done on it by the net force This is about the work energy theorem, and that is we shall generalize the above derivations to verifying the forces in the later section. Now we go for the numerical here, that is the another numerical and the second numerical of this unit. Let's go for the same. The question is, it is well known that the raindrop falls under the influence of the downward gravitational force and the opposing resistive force. The latter is known to be proportional to the speed of the drop but is otherwise undetermined. Consider a drop of mass 1 gram falling from a height 1 kilometer. It hits the ground with a speed of 50 meters second inverse. What is the work done by the gravitational force? The second is, what is the work done by the unknown resistive force? So let's go for the same here. So here we go. It is well known that a raindrop falls under the influence of the downward gravitational force and the opposing resistive force The latter is known to be professional. Is known to be professional to the speed of the drop. But is otherwise undetermined. Undetermined. Consider a drop of mass (1 gram) falling from height 1 kilometer it hits the ground with a speed of 50 meter second inverse. What is the work done by the gravitational force? Force. What is the work done by the unknown? Unknown resistive force. So we'll go for the scene and we'll find out the solution here. So here we go for the first one. The change in kinetic energy of the drop. The change in kinetic energy of the drop is delta K half mv square equals minus 0. So half into m is 10 to the power minus 3 into 50 into 50, which is equals to 1.25 joule. Now where we have assumed that the drop is in initial at rest, so I mean assuming that G is a constant with the value of 10 meter per second. Let's go for it. Where we have assumed that the drop is initial at rest. So assuming that, here we go. So assuming that G is constant with a value 10 meter per second squared. The work done by the gravitational force is W is equals to mgh, which is 10 to the power minus 3 into 10 into 10 to the power 3 equals to 10 joule. So for second one, that has been asked from the work energy theorem. Delta K equals to Wg plus Wr, where Wr is the work done by the resistive for on the raindrop. Thus Wr equals to delta K minus Wg equals to 1.25 minus 10 equals to minus 8.75 joule. Negative. Is negative here. Now we talk about for the work here, and that is about the work which is in the detail about it. So work, and then we'll discuss about the kinetic energy. After that we discuss about your work done by a variable force. So and here we going to end up with, and we'll discuss in the next coming class. So thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion and a comment box. Please like, share and subscribe so that many maximum people can get the information at once, and even though you can also enjoy the video as well. Thank you.